Hi everyone, it's Math with AUB. Today's frame is based upon the selection of first year questions. First year questions from past papers, especially from Aga Khan board, especially from the courtesy of Aga Khan board. Question number one reads as what the range of the trigonometric function, range of trigonometric function 3 over 2 times cos pi plus 2 theta, where limit of the value of theta is given to us the closed interval from 0 to 2 pi. From 0 to 2 pi. From 0 to 2 pi. If we put 0 here, it will give us cos pi, means these are the values to be minus 1 to 1, or we are simply familiar the range of sine and cosine is minus 1 to 1. The range of sine and cosine is minus 1 to 1. Minus 1 to 1. Just multiply this quantity, whatever it is, it will become minus 3 over 2, comma 3 over 2. The closed interval from minus 3 upon 2 to 3 upon 2. That is our range. Normally, the range of sine and cosine is from minus 1 to 1, inclusive, including minus 1 and 1, the closed interval, minus 1, closed interval, 0, the closed interval from minus 1 to 1. That is the range of the sine as well as cosine. This period is defined 0 to 2 pi, that is period of cosine, that is period of cosine 0 to 2 pi. Let me give you idea how to find period of such type of function. Period, normally the period of sine and cosine, period of tan and cot is pi. Normally the period of tan and cot is pi. The rest four functions, sine, cos, sec and cosec, their period is 2 pi. Normally the period of tan and cot is pi. The period of the rest four functions, sine, cosine, sec, cosec, is 2 pi. If the inclination, if the angle is not simple, then how to arrive at the period? Let's see and find out. Take this one. Normally the cosine period is 2 pi. Whatever the inclination is, right, pi plus 2 theta is equal to 2 pi. Now solve for theta. Solve for theta. Normally the period of sine or cosine is 2 pi. Here it is cosine. I have written cosine. What is inclination? Pi plus 2 theta is equal to 2 pi. Solve for theta. Theta is our period. 2 theta is to be 2 pi minus pi. 2 theta is our pi. Our theta is pi over 2. Pi over 2. That is the period of this function. Period is pi over 2. Pi over 2. One can verify whether the period is pi over 2 or not. Let's see and find out. Cos pi plus 2 theta. 3 upon 2 cos pi plus 2 theta is pi over 2. 2 cancelled out. 3 over 2 cos pi plus pi. It will become cos 2 pi. Look at this, cos 2 pi. We arrive at the same result. That is the normally period of sine cosine is this one. Normally the period of cosine is 2 pi. Take the inclination pi plus 2 theta. Solve for theta. Solve for theta. That is our period in that case. That is our period in that case. Question number next is also connected with this one. We are asked to find what is the period of the trigonometric function cot x over 9. Cot x over 9. Cot x over 9. Let's see and find out. Period of cot x over 9 is what? Normally the period of tan and cot is only pi. Normally period of tan and cot is pi. Whatever the inclination, right, x over 9, solve for x, solve for x, solve for x, inclination is solve for x, x is equal to 9 pi, x is equal to 9 x is equal to 9 pi. If you put here, you can verify cot x means 9 pi over 9, 9 and cancel. We have pi, that is the period of cot. That is the period of cot. That is the way of finding the period. That is the way of the finding the period. If anything is in division, then multiply with period. Anything is in multiplication, divide. But this is the best strategy. Inclination to be taken is equal to normal period. Inclination to be taken is equal to normal period. Solve for the variable angle x. Solve for the variable angle x. Okay. Second question is based on trigonometry as well. A cos inverse of or cos of negative 1 upon 2. Negative 1 upon 2. Negative 1 upon 2. Negative 1 upon 2 when cos is 120 degrees. Cos negative 1 over 2 is cos negative 1 over 2 is when angle is 120. Convert the angle from degree to radian. 120 times pi over 180. Cancel out table of 2. Table of 6 2 times, table of 6 3 times. It is 2a pi over 3. 2a pi over 3. The value of this quantity a times cos inverse of minus 1 over 2 is 2 pi a over 3. Option C. Option C in that case. Minus not to be ignored. Minus not to be ignored. Minus not to be confused with cosine is even function. Here cos is inverse. We have to take care of the quadrant. According to quadrant, we have to select the angle. Okay, cool. Moving to next question. The last term of sequence is given by Tn is equal to 4 times n minus 3 is 33. The number of the terms in the sequence is to be found out. Let's see and find out what is this. Question number 4 it is. Question number 4. We have last term. Last term, sometimes it is also called nth term or general term. General term. Some write Tn, some write as right, and both are correct. We have given nth term is 4 times n minus 3 and the last term is 33. Last term is 33 is equal to 4 n minus 3. Then we are asked how many terms, how many terms, how many terms means n we have to find out. Shift 3 there, 33 plus 3 is equal to 4x, 4n, 36 is equal to 4n. Dividing with 4 to solve for n, 36 over 4, 4n over 4, 9 times. So n is equal to 9, n is equal to 9, n is equal to 9 in that case. One can verify by putting n is equal to 9 in the general term, the last term, Tn is equal to 4 times n minus 3. We have arrived, it is the ninth term, Let's see and verify. 33 is the ninth term, 33 is the ninth term. Let's see and verify. T is 9, 4 times 9 minus 3. 4 times 9, 36 minus 3, yeah, that's equal to 33. Yes, the ninth term is 33. We have verified as well. Another question based on combination, or you can say Pascal rule, combination property, a really very simple one, but effective one. 100 combination 40 is equal to what? The magic identity works here is this. NCR is equal to N CR n minus R. That is the way. Add them up, you will get same n. N minus R plus R, you will get n. That is the strategy. Means it is equal to 100 combination C 60. 100 combination C 60. One can easily verify without calculating. Let's see and find out. Expand this. Open up 100 factorial over 40 factorial. 100 minus 40 factorial. 100 minus 40, it's 100 factorial over 40 factorial. 100 minus 40, it's equal to 60 factorial. Okay, what about right hand side? 100 factorial, 60 factorial, 100 minus 60 factorial. Same 100 factorial, 60 factorial. 100 minus 60, that's our 40 factorial. Look at this. Each and everything is same. 100 factorial, 60, 60, 40, 40. So that is the magic that works here. NCR is equal to n combination C n minus r, n minus r. Add them up, you will get you will get n. It's equal to n that I have already done here. Okay. Next question, based on mathematical induction generalization. By the math principle of mathematical induction, to prove that 1 cube, 2 cube, the sum of the cubes of first k natural numbers is equal to k square plus k plus 1 whole square over 4. For k plus 1th term, the term should be added. Means what should be added in order to prove it? To prove the third step, let me write the identity. 1 cube, 2 cube, 3 cube dash 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 plus k cube is equal to k square times k plus 1 square overall 4 square. Put k is equal to 1 or n is equal to 1 to verify n is equal to 1. Step 2, suppose it is 2 for n is equal to k. We are asked to find third. For third step, what is to be added? Take the last term, take the last term, take the last term, take the last term. Left hand side last term of the left hand side, last term of the left hand side. Replace k by k plus 1. Replace k by k plus 1. Take the last term from the left hand side, last term of 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 the left hand side. Replace as many k's by k plus 1. We have to add this thing on both sides. So our answer in that case is k plus 1 whole cube to be added on both sides. I can verify you as well. K square times k plus 1 whole square over 4 plus k plus 1 whole cube. Taking k plus 1 whole square common, taking k plus 1 whole square common, we have k square over 4. What remains here? K plus 1 raised 1. Taking LCM, we have k plus 1 whole square, k plus 1 whole square, k square, taking LCM, 4k plus 1 over 4, or one can say k plus 1 whole square multiply 4 throughout, k square plus 4k plus 4 divided by 4. It is the perfect square quantity of k plus 2 whole square, or one can use middle term breakup. We arrive at k plus 1 whole square times k plus 2 whole square over all 4. Look on the left hand side, in the last term we have managed k by k plus 1. We have managed k by k plus 1 from our own side. Look at this. This is k. Now we have k plus 1. There is k plus 1. We have there k plus 2. Means automatically k has been replaced by k plus 1 on the right hand side. We are simply asked what should be added, k plus 1 whole cube to be added on both sides to get along the third step, but I have verified you as well. Okay, moving towards next question, that is 1 plus x raised minus 2. Expand this, open this up. Binomial expansion when power is negative or fraction. Let's see question number 7. 1 plus x raised minus 2. When it has negative power or fraction power, negative power or fraction power, it has infinite terms. It has infinite terms. It has infinite terms. It has infinite terms. How to open this up? Really very simple. 1 raised minus 2, drag the power down, make the power coefficient, drag the power down, subtract 1 from the power and introduce the second term. 1 raised minus 2 minus 1 times x over 1 factorial. Similarly, make this power coefficient again, drag the power down. Okay. 1 raised minus 1, 1 raised minus 2, drag the power down, minus 2. Subtract 1 from the power, minus 2 minus 1. Introduce second term x power 1 overall 1 factorial plus minus 2 has been already dragged, now dragged minus 2 minus 1, again subtract 1 more, it will become 1 raised minus 2 minus 2, raise the power of x instead of 1 x square, now multiply by 1 into 2, same we have dragged minus 2 minus 2 minus 1, now minus 2 minus 2, subtract 1 minus 2, instead of minus 2 subtract 3, now x cube overall 1 into 2 into 3 and so on. Now whatever the power of 1 it is 1, whatever is power of 1 it is 1 minus 2x. Now it is minus 2 minus 3, whatever the power of 1 is 1 x square over 2, 2 cancelled out, we have here minus 2 minus 3 minus 4, whatever the power of 1 it is 1 x cube overall 1 into 2 into 3, 3 cancel, 2 cancel, now manage this one, 1 minus 2x minus minus plus 3x square minus minus plus plus minus minus 4x cube and so on. That is our expansion of this one. 2 to 3 terms are enough. I have managed 4. So our option number A is the right option. Option number A is the right option. Whenever binomial expansion has negative power or fraction power, it has infinite term. It has infinite term. And we are familiar, combination doesn't work for fraction or negative. Combination doesn't work for fraction or negative power, for negative terms. The final question that is, both the roots of quadratic equation, it's a tiny quadratic equation, are complex if, when roots are complex, simply kx square minus 4 is equal to 0 or kx square is equal to 4, x square is equal to 4 over k or x is equal to plus minus times 4k. We want them to be imaginary, then k must be less than 0, k must be less than 0. If k is less than 0, then we introduce here iota, or one can use the appropriate orthodox method, b square minus 4ac less than 0, b square minus 4ac less than 0, the discriminant. When the roots are negative or complex conjugate, then discriminant is less than 0. Here kx square x power 1, x raised 1 term is missing, right, 0x minus 4. Now that's our value of A, that's our B, that's our C. Put here B square means 0 square minus 4, A means K, C means minus 4 less than 0. So we have minus plus 16k less than 0, or k is less than 0 over 16, k is less than 0 over 16. So k is less than 0 is the required condition in that case when both roots of this quadratic equation are complex. Both roots of this quadratic equation are complex, or one can verify by putting any negative value. Say suppose minus 2x square minus 4 is equal to 0, minus 2x square is equal to positive 4. So x square is equal to minus 4 over 2. Taking the root of negative 2, we have negative 2 means plus minus root 2 iota. Our orthodox method, when discriminant is less than 0, discriminant b square minus 4ac less than 0, then we have roots complex conjugates. Such type of roots are possible, a plus b iota and a minus b. Whenever the discriminant is less than 0, roots are complex conjugate. It's my tiny effort for you guys to give you some concept how to clear exams, rather than boasting or saying that we are all in all. I am nothing, just keep on working. Simple things, little drops of water make the mighty ocean. I am of that opinion. Don't claim it is not necessary you have trick for every question, different trick for different question. No, you should have concept, clarity, vision and apply them. You are going to work wonders. It's all by itself. Next